Hello, this is our final presentation for our crime analysis senior design project.
I'm Darius Grosh. I worked on collecting data and analyzing it to show the data through different visualizations.
I'm Michael Donahue. I focused mainly on creating scripts to gather and standardize the data.
My name is Suyash. I worked in the back end when it comes to Python scripting and collecting data.
My name is Grant Fecto. I worked mostly with the map visualization and some of the front end.
My name is Sean Gillick. I worked a lot on our AWS hosting and Git management.
My name is Joshua Jacob. I worked on the documentation and also worked with Mike on standardizing the crime types.
Here we also wanted to mention our advisor Malad, who guided us through our project planning and creation phases, as well as Kartik Vora, who is a graduate student at Drexel, who helped polish our front-end UI.
So what is our project? First of all, our problem statement. When we came into this, we looked around a lot and we found that there weren't a lot of ways to easily compare crimes between cities without going directly to the city and opening up multiple pages and kind of looking at it that way. So we wanted to make something that allowed you to take a city or multiple cities, compare the crime, visualize it, look at it, and figure out kind of what it looks like in each place. So it's a website that uses data that's gathered from individual cities' reports and takes that data, it standardizes it, and it allows the users to view it, compare it, and analyze different criminal activity. So there's a large amount of crime data that is taken in, and we use that to create charts, maps, bar graphs, anything you really need to compare them. We hope that this website overall will help people kind of understand the cities around them, maybe places that they're planning to move or planning to rent, and just get a better idea of the crime statistics in their city compared to others.
Our project and other work in this domain. Neighborhood Scout is a website which goes into details about an area, real estate, demographics, crime, schools, and trends. And it also provides general information in all the above topics. Our project, Crime Analysis, goes into specific details of the crime statistics and allow the user to compare crimes in the area to a specific address. Open data and government data websites. Uh, each city in our database has their own open data or .gov website where data is hosted and displayed in various ways. For one city, it provides a lot of same data that we have, but cannot be used to easily compare cities or to calculate the safety of a given location with the set radius within a city.
One of the biggest goals for this project was to give users an ease of access to crime data in some of the largest cities in the US. This allows them to easily evaluate places they may want to move to from the data we present in graphs, charts, and maps. This is done through data collected over multiple years in order to help users see trends that may be happening. They can easily compare US cities to others and find detailed information about the crime that is happening around a specific address compared to the rest of the city. Potential stakeholders will be people looking to move to a new city and who want to evaluate specific parts of the city to the rest. A use case could be someone on Zillow, Apartments.com, or Trulia and want to see the safety score of a neighborhood.
When getting started with this project, the first major component we needed to set up was our data. And we found that there were various different types of data that we needed to gather. The first being crime incident reports. For this, fortunately, there was an API, the SODA Socrata Open Data API, that had information for a good amount of cities in the US. So we were able to create scripts that would access that API and get data for most of the cities that we have. However, for some of the other cities, we needed to go to various websites and download CSV data for those cities. The next bit of information we needed for each city were city populations. And that way we could use that to help normalize the data and for some different calculations that we would display. Fortunately for that, there was one CSV we needed to download, and it had populations over the years for the largest cities by population in the US. Another bit of information we needed was the city area, and that would help us in our safety score calculation that we'll talk about later in this presentation. For that, we just manually scraped the web and gathered that information. And then the last bit were the city latitude and longitudes, and these are the lat longs that represent the center of each city. And we needed this information so that we could pinpoint the city on our heat maps that we generate, which again, you'll see later on in the presentation. And for that, we used API ninjas. They had a good city API that we could easily tap into and get that information. Once we had all of our data collected, we noticed that it was all in different formats. Each city crime reporting systems were a little bit different. So we needed to go through and standardize that so that it was all the same when the user would visualize it. The first thing that we did was standardize the date format just to make sure that was all unified. So we created a simple script to go through all of our city CSVs and format that. Another thing we needed to do was standardize the latitude and longitude. Many CSVs that we downloaded had the latitude and longitude values stored as a dictionary in one column. However, when we were storing it in our backend, we had them separated. So we just needed to create a couple scripts to go through and extract those values. Another problem we had with the latitude and longitude values were that some cities didn't even have them. Instead, they just gave us street addresses. Fortunately, we were able to create a script that would loop through all those addresses and geocode them using an OpenStreetMap API, which was free to use. But the major thing that we needed to standardize were the different crime types. We quickly noticed that every city labeled their crime types differently. So after doing some research, we found that the FBI has a unified crime reporting system, and we decided to use that to standardize these crime types. And it's split into violent, property, and other, depending on the severity of the crime. So we made a script that goes through all the different crime types for each city and categorizes them by these standards. So once we had all the data collected and all the data standardized, the last thing to do was aggregate the data. And we did that for the crime totals for each city for each year, as well as the crime totals per crime type for each city for each year. So we did those calculations and decided to store that as well. And the reason we did that was so that every time the client wanted to access this information, we didn't have to calculate it on the client side. We could just easily access those numbers.
When it comes to our backend, we decided to use a Flask server to handle our incoming requests, as it was easy to use with our Python scripts that we had set up. We also used AWS a good amount. On AWS, we used an RDS database using MySQL, which allowed us to store all of our reported crime data into a database. We then used Elastic Beanstalk, which was an environment which allowed us to host our application live. And then lastly, on AWS, we were able to use a code pipeline to link up to our Git repository. So anything that got pushed into our Git automatically got detected, and new changes were then built directly into our live web page. And then we also had various scripts written in Python, which were used to collect, standardize, and then load data into our database.
For the front end, we used help from different packages so we could easily represent the data we collected. Through Plotly, we were able to generate charts such as sun graphs and line graphs. In order to generate different kinds of maps, such as heat maps, we used Folium to help visualize the density of crime in specific parts of the city. These were all done on the back end and being generated at the Flask endpoints before generating them on the web page. We use HTML to create the front end and use Bootstrap to help build a clean and responsive design. Jinja helped generate some of the HTML content by allowing us to put Python code on the front end and easily use the data generated from the backend endpoints.
Now let's talk about some of the tools we use to manage our project. We use Trello for assigning tasks to each member of the team and tracking task progression. We use Git for collaboration on development and version control. We use Discord for daily communication between members. We use Zoom for meeting with our advisor each quarter. We used When to Meet to set up meetings with our team members. And we used Figma, which is an interface design tool, which we used to help design our first demo.
But now we will have a demo of our project. The top link is our live webpage. Feel free to go to that whenever you want. If you're watching this at home, and take a look. For now, we're going to use the local because there are some current issues that we have with the power of our server that just make loading and processing some of the data a little hazardous. So we'll start with Philadelphia. Here's our homepage. If you scroll down, there's just a few blurbs here about what this is about and the benefits that it brings. We'll click Generate Analytics. And here we get taken to our first page. This is our charts page. We can see that 9 people out of 100 are victims of a crime in a given year. And we can see this comparison on this line graph of the rate of crime that happens in Philadelphia over the years. So 2020 hits, that's when COVID starts, and you see a huge dip, which is about expected. Most cities will have this. Down here, we see Philadelphia compared to the other cities that we have in our database. It's highlighted here. So you can see that in terms of total crime, it's pretty high up there. Here we have our sun graph. This is a breakdown of all the crime types that we have in Philadelphia. So you can see that a good amount of them are other. There's a decent amount of property and then a much smaller amount of violent crimes. And these get broken down into even smaller categories. So we can see specifically what's happening here. Very small amount of arson, but it does happen in Philadelphia. Here's our yearly crime count. Once again, just kind of a line graph showing the actual count of the crimes. Once again, a big dip in 2020 when COVID happened, in 2021 when it was still occurring. And here is our pagination. This is just a massive list of all the crimes. So if you want access to all of this, then it's right here. So you can click through these pages and just get a huge view of all of them. So going back up to the top, we'll go to our heat map next. This will generate a heat map by default for all of our years and all of our crime types. But if we want, we can change that and get a heat map that's based just on certain types of crime and certain years. So this is all. We can see that there's 2 big red zones right off the bat. One's in Center City and one's up in Kensington area and then in northern Philly. So this will help users kind of understand what parts of the city are, more dangerous than others in terms of local crime, and kind of get a good view of what is happening around them. This can be used kind of in tandem with our safety score page. So say that you find a location such as this, where there's a lot of crime on 1, 2, 3, 4 Market Street here. We can go to our safety score page and we can put in a 1 mile radius, let's say, for 1, 2, 3, 4 Market Street. Here we have our autofill as well. That's taken from like an address or API. So we put in our Market Street, we hit calculate. We can see our overall safety score is 1, which means that it is very unsafe compared to the rest of Philadelphia, which sounds about right for how red that was on the heat map. We can see the scores throughout the years here. It's been 1 for all 3 of the years that we have. And we have 2 maps that are currently loading. These maps are going to show us the crime types. So you can see the distribution of violent, property, and other, as well as the grouping and amount of crimes that are in that area. So this will take a little bit to load because there's a lot of data. But once it's up, we'll take a look at the maps. All right, so our first map is in. We can see there are quite a lot of of crimes here. If we want, we can uncheck these boxes. So say we don't want to see our violent crimes, we can see all our property crimes. If we don't want to see those, then we see all our other, and so on. So this way you can kind of see the distribution of the crimes across this area, this 1 mile radius based on that address. On the right here, we have a cluster map that is made up of different markers that cluster together, kind of show you the overall amount of crimes in each place. So if we zoom all the way out, we can see that within a 1 mile radius from that address we put in, there are 22,000 crimes over 3 years. So that's a good amount of crimes. We can zoom all the way in here. We can see this is the exact location that we put in where that big red spot was on the heat map. If we click this, it'll expand out into a huge cluster of crimes. Now, this is a little hard to read, but you can see that in each location, if you go in far enough, you can see each kind of crime. So we've got property, which is the blue house, violent, which is the red exclamation mark, and other, which is this kind of orangish eye. So using this tool, hopefully people can find good ways to judge the safety of their areas around them and figure out if moving somewhere or traveling somewhere is a good idea for them. Now we can take a quick look at our GitHub repo.
Yeah, so moving on to our GitHub repo, one of the main things that we kind of first ran into was storing all of the CSVs for our data. Since these files are up to kind of hundreds of thousands of lines, we had to add Git large file storage, which allowed us to store all of these big CSVs, both unparsed, and then after standardizing, we also were able to store our standardized CSVs. And then through this, we're able to have kind of pages separated from the rest of our scripts. So if you go into the templates folder, this is where we store all of our HTML for our charts, our graphs, safety score, everything else. And then lastly, if you scroll down to the bottom, this is where we have all of our main scripts as well as our README. And in this README, it provides a little description about what our project is, kind of who we are as a team, and then as well, kind of how to run the project locally using our virtual environment that we have pre-set up.
Here are some of the limitations that we faced while working on our project, or some of the limitations that our project currently have. The Google API that we use to generate the address in our safety score page has only 30,000 free calls per month, and we need to pay money for more calls. The Socrata API that we use to pull crime data cannot pull data automatically for the upcoming years. Crimometer was another API that we tried to pull crime data, but we only had 20 calls per month. And also it requires $3,000 for additional calls. So we didn't use this tool. As we mentioned, GitHub, we use GitHub to store all of the data. But if we decide to add more cities or add more years of data, we might need to buy a different plan for more space. Limitation in AWS. Our server has less memory, and which leads to timeout during big request, and we need to pay more money for a better plan. And our product only has crime data from 29 states in the US.
So this is a summary of kind of our work throughout the quarters, just to give an idea of how our project progressed. So in the fall quarter, we started by collecting large amounts of data from various sources, as mentioned previously, and then focused mainly on kind of getting that data, starting to standardize it, and creating a very basic website that can connect to a database and load the data into its UI. In our winter quarter, we really focused more on standardizing the data, got all of our dates standardized and our crime type standardized, and we started creating new visualizations for the data rather than just table pagination. So this is when we started working on charts and maps to really show off our data in a useful way. And finally, in the spring quarter, we polished up our visualizations and polished up our UI and kind of optimized whatever we had in the back end and implemented data caching and things like that to make our project just run a little smoother overall.
Yeah, and moving on to our next steps. So although we did a great amount of work over the last 3 terms, there can always be a little bit more to kind of refine our project going into the future. So the first thing that we want to update is our safety score routing. So we're currently returning our safety score kind of inside of like a template, which includes extra information regarding the web page itself, rather than just the safety score. So if we update this and how the data is returned, people will be able to use like curl request, where they enter a specific location and radius, and it provides only the safety score. So this will allow sites like Zillow or anyone else who wants to just do a quick request based on like a set location, they'll be able to grab just the safety score. The next thing we want to do is upgrade our server capabilities. So as we mentioned in the limitations, we're running into memory issues with our AWS server, which is causing some big queries to kind of time out on the live server. So upgrading this to a more memory inclusive server should resolve those issues. We'd also like to resolve some of our issues with like current existing cities, one of which is Houston, Texas. The kind of issues with this is that the latitude and longitude aren't correctly lining up with how our heat maps are generating. So a lot of the heat maps aren't able to properly generate for that city. As well as we would like to get more information on more cities. Right now we're only up to 29 cities, but it'd be nice to have at least one major city in each state across America. And then lastly, we'd like to optimize our database queries just to kind of speed up the loading on our web page, mainly the like charts as well as the heat map loading times. And then for our acknowledgements, we'd like to once again say thank you to our advisor Malad. He helped a great amount during our project planning and creation phases, and he was able to provide valuable insight in how to improve our project every step of the way. For our UI help, this was Kartik Vora. As I mentioned earlier, he's a graduate student at Drexel, and he helped us kind of polish and refine our front end of our project, specifically making our project pages kind of load dynamically rather than refreshing the entire page every time a chart selection is toggled if you want to do 1 year rather than all 3 years. And then lastly, Arash. He is a friend of Malad, and he gave us great advice on kind of industry standards and best practices and just additional ways to improve our front end as a whole.
And that's it. Thank you for watching our presentation. We hope you enjoy. Make sure you try it out with that live link that was shown earlier. And yeah.